Hi everyone, my name is Dhruba Joshi and I have been working as a senior SAS developer position for a couple of years. In my time, I have collected a few interview questions and I would like to share them with you. If you have questions of your own, please email me. Thank you.
SAS interview question and answer question number 47. What do you mean by SAS macro and what is its use? This question is asking about definition of SAS macro and where and why do we use it. SAS macros are compiled SAS programs that we can call in a submitted SAS programs or from command line. SAS macros are powerful feature of SAS programming language which allow to avoid repetition of the code and allow to use them again and again as needed. It decreases the lines of the code drastically and code works faster and efficiently. To expand the use of SAS macro, I am going to explain three different sample scenarios. Sample scenario 1. Suppose we have 1000 lines of SAS code and start underscore date is included in the code more than 200 places and we change it every week. It is tedious to go to the code every time and change the date in each place. In such a scenario, we define macro variable first and invoke that value for every start underscore date. In this case, we use percent late stdate where stdate is SAS macro variable and value is suppose 12 Feb 2023. Then replace the value of start underscore date by ampersand stdate dot. That means we are calling the value of this stdate which is 12 Feb 2023. Ampersand stdate dot that represents the value of this stdate. That's why start underscore date equals to ampersand stdate dot. Then every week just change the stdate at one place. Then it will replace every start underscore date value. That means every week just we have to change this place here. That means in place of 12 Feb 2023, we can change the value as required and run the code. Then it will change the value of start underscore date everywhere. This is the first scenario. Sample scenario 2. Suppose we need to calculate descriptive statistics of numeric field of 10 different tables. That means we have to calculate number of records, minimum value, maximum value, mean value, standard deviation, number of missing value, and so on. In this scenario, coding proc means procedure for 10 different tables is not efficient way because it takes more time and code becomes very long and it is not effective. Then one SAS macro programming is sufficient and pass parameter into it as required. That means just we have to provide table name 10 times, then it will calculate descriptive statistics of each table. Sample scenario 3. Suppose you have monthly snapshot data in your database from Jan 2002 to December 2022. That means 20 years data. Your job is to combine or compile all month and year data without duplicate records. In this scenario, selecting all fields and using union operator in each month is very tedious job because we have to write the same code 240 times, which is time consuming task and not efficient. So in such a scenario, we use SAS macro with parameters. That means just we have to provide a starting and ending date, which is sufficient to combine the data. In this way, we can use SAS macro in SAS programming language. That's all about question number 47. Thank you.
SAS interview question and answer, question number 48. What do you mean by SAS macro variables and what are their types? This question is asking about definition about the SAS macro variable and its type. SAS macro variable in SAS is a string variable that allows to modify the text in the SAS program. It is used to store a value in SAS which is always character and can hold character, number, or text. Macro variables defined by the SAS programmer are called user-defined macro variables, and those defined by the macro processor are called automatic macro variables, which are global macro variables. We can define and use macro variables anywhere in SAS program except within data lines. User-defined macro variables are two types. First one is local macro variables. Then second one is global macro variable. Let me explain first local macro variable. When the macro variable is defined inside the macro, that means SAS macro code, then it can be applicable only in that macro and value available only until macro stops executing. Such type of the macro variable is called local macro variable. That means local macro variable is defined inside the macro code and its value is effective only inside that macro. We cannot use outside the macro. A sample code is given here. %macro ABCD is macro name. A user-defined local macro variable DSN is used, and another local macro variable XY is used with the help of %let. %let XYZ equals to 12. That means local macro variable is defined inside the macro, and we are going to print a report. Suppose title is report print local macro variable, proc print data. We are calling local macro variable DSN, where age equals to $xyz. We are calling macro variable xyz. Run macro close, and we are calling macro abcd here %macro by providing sasshelp.class dataset. When we run first set up the code, then we will get result as shown on the right side. The title is report print local macro variable, and from this table it is clear that age variable contains only age 12. That means local macro variable has a resolve. XYZ has a resolve. As a result, we observe this result, which includes age equals to 12. From log window, we observe there are 5 observations read from the dataset sasshelp.class where age equals to 12. That means local macro variable xyz has a resolve. Let me explain about the global macro variable. When a macro variable is defined in a statement outside the macro definition or automatically created by the SAS session, then the macro variable can be used anywhere in the program and it gets removed at the end of the session. Such type of the macro variable is called global macro variable. That means global macro variable are defined outside the macro, and system defined macro variable are also called global macro variable. Sample code is given here. %let PQR equals to 14. Here PQR is user defined global macro variable where its value is 14. We are going to use global macro variable PQR inside the macro code. %macro ABCD Title is report print global macro variable. That means we are going to print another report. And another line is printed on ampersand sysdate9. That means sysdate9 dot we are using here, where sysdate9 is global macro variable, which is system defined macro variable. Proc print data equals to ampersand dsn, we are calling dsn here, where age equals to ampersand pqr, we are calling global macro variable pqr. Run, closing macro, and calling macro by providing SAS help.class dataset. When we run second set of the code, then we will get result as shown on the right side. The title is report print on global macro variable printed on 19 Feb 2024. That means sysdate9 global macro variable has resolved because it is system defined macro variable and global macro variable, it has resolved to the today's date. And from this table, age variable shows value 14. That means global macro variable PQR has resolved inside the macro. As a result, we observe the result which includes age 14. Next step, we are going to check local and global macro variable outside the macro. First of all, I am going to check local macro variable. Proc print data SAS_help.class, where age equals to ampersand xyz, where xyz is local macro variable which is defined in previous slide inside the macro, and run. When we run this third set of the code, then it will display error message as shown on the right side. It says apparent symbolic reference xyz not resolved, because xyz is local macro variable, it cannot be resolved outside the macro. When we run the same set of the code with a SAS window, this is the first set, that is the use of local macro variable, because this %let xyz equals to 12, this is the local macro variable which is defined inside the macro. When we run first set of the code, then it will display the result exactly same as we explained before. Title report print local macro variable, and table contains or includes age equals to 12. That is local macro variable has resolved. Let me go back to the code and run second set of the code for global macro variable, where we have defined global macro variable PQR outside the macro, but we are using this global macro variable inside the macro. Let me run the second set of code. We will get the result. Title is report print on global macro variable printed on 19 Feb 2024. That means system defined global variable has resolved. And table contains age 14. That means global macro variable PQR has resolved. As a result, we get this table which contains age equals to 14. From third set of the code, we are going to check whether local and global macro variables can exist or can applicable outside the macro or not. Let me check first local macro variable. Proc print data SAS_help.class, where age equals to ampersand xyz. That means I am going to use local macro variable and run this code. then it throws error. That means apparent symbolic reference XYZ not resolved. Because XYZ is local macro variable and we are going to use outside the macro, that's why it cannot resolve. As a result, it is throwing error and it says that XYZ not resolved. Then similarly, let me check global macro variable. I'm commenting this part first. Second part, I'm using global macro variable PQR. Let me run this code. Yes, it says the result. It displays the result. That means age is 14. From here, it is clear that user-defined macro variables are two types, local macro variable and global macro variable. Local macro variable is defined inside the macro code and applicable only inside that macro. We cannot use outside the macro. But global macro variable is defined outside the macro code, or system defined macro variable are also called global macro variable, which can be used outside and inside the macro as well. That's all about question number 48. Thank you.
SAS interview question and answer. Question number 49. How can you check the types of macro variable in your SAS program? This question is asking about what type of macro variable present in your SAS program. To check local macro variable, we write %put underscore local underscore semicolon inside the macro code where local macro variable is defined. And to check the global macro variable, we write %put underscore global underscore semicolon anywhere in the code. Anywhere in the code, that means we can write inside the macro as well as outside the macro throughout the program. Alternatively, we can write %put underscore all underscore semicolon inside the macro that displays local macro variable defined in that macro and displays all automatic and global macro variables. Sample code is given here. %let A, its value is Toyota, where A is global macro variable because A is defined outside the macro. %macro, macro name is test. Inside the macro, we have defined two local macro variable, DSN and var. Again, %let B, B equals to sedan, where B is local macro variable. It is defined inside the test macro code. We are going to create a frequency table, proc data, %DSN, that means we are calling here DSN value. Then table %var, where type equals to %b. That means we are going to filter using the type equals to %b. That means the %b value is sedan. Run %put underscore local underscore. That means it displays the local macro variables. %mint, it is going to end the macro. %test, we are going to recall macro. And inside the parenthesis, we are going to provide value of DSN and value of var, where value of DSN is saself.cars and value of var is origin. Then finally %put underscore global underscore. When we run the set of the code, then we will get result as shown on the right side. This is the frequency table we observe from the result window. And we are going to check the types of variable. That's why we are going to observe log window. From the log window, we observe following information. Test B sedan, test DSN saself.cars, test var origin. That means test is macro name, B, DSN and var, these three are macro variable. These three variables are inside this test macro. That's why these three variables are local macro variables. And value of B is sedan, value of DSN is SAS cars, value of var is origin. Then similarly, global A Toyota. That means macro variable A is global because we have defined outside the macro. If we run same set of the code with a SAS window, then we will get exactly same result. This is exactly same code. %let A Toyota, %macro test, two variable DSN and var. These two are local macro variables. %let B is also macro variable, but it is local. Procfreak data ampersand DSN, table ampersand var, where type equals to ampersand B. That means we are going to filter, run, and %put underscore local underscore, it displays a local macro variable. %end, end, that means that we are ending macro. %test calling macro and providing the value of DSN and var. %put underscore global underscore, it displays the global macro variable. When we run this code, then we will get result as shown on this window. This is the exactly same result we observe, and we are going to check the log window. From log, B, DSN and var, these three variables are local macro variable because these three variables are inside this test macro. That's why these three variables are local macro variables, where A is global. It is given here global A, that means A is global macro variable because A is defined outside the macro. The next one is alternatively I am going to comment %put local and uncommenting this second part. That means %put all, and again I am going to comment %put global. That means just I am going to write %put underscore all underscore inside this macro. Then what will happen? Let me check them. Then we will get exactly same result. And from the log window, we observe here variable B, variable DSN and var. These three variables are inside this test macro. That's why these three variables are called local macro variables, where value of B is sedan, value of DSN is SAS class, SAS cars, and var is origin. And another variable is global, that is the A is global because A is defined outside the macro. And furthermore, it displays all global macro variable as well as all automatic macro variables. That means that those macro processor are defined variables are called automatic macro variables. Those are also defined or displays here. In this way, we can check local or global macro variable present in our SAS code. That's all about question number 49. Thank you. SAS interview question and answer. Question number 50. What are the different ways to create SAS macro variables? This question is asking about what are the different ways we can create SAS macro variable. There are 5 different ways to create the SAS macro variables, briefly defined as follow. Number 1, using %let statement. By using %let statement, we can define macro variable inside and outside the SAS macro code. If we define inside the macro code, then it is called local macro variable. If we define outside the macro code, then it is called global macro variable. Syntax is given here, percent %let macro var name that represents macro variable name we have to provide here equal value. That value represents the value of macro variable which we have defined. Number 2, call simput routine. This is the second method. This is a procedure. Routine, that means that this is the procedure that can accept arguments but does not return any value. By using call simput, we can change data step variable into macro variable, and syntax is given here. Call simput, inside parentheses we have to provide macro var name, that means macro variable name, which should be inside the quote, comma, and value. That means macro variable name, first part is that is the variable name, and second value represents the value of this macro variable. Number 3, iterative %do. This is the third method. For dynamic programming, we use macro %do loop. The iterative %do loop is similar to do statement used in data step, but %do can be used anywhere inside macro and used for increment macro variable. Syntax is given here. %do macro variable name we have to provide here equal starting value %do stopping value, where start value represents the starting value of macro variable, stop value represents the stopping value of macro variable, and sometimes we use increment step, that is percent by increment value, which is optional. After then we provide SAS code and %end. When we start with %do, then we have to end with %end. Number 4, macro parameters. This is the fourth method. This is a way to create a piece of code that can be run multiple times. A macro needs to be started with %macro and ended with %mend. And you can use parameter to change the value for each run. Just changing the parameter, we can get the different value, but we run the same set of code. Here, %macro, this is the starting point, %macro, macro underscore name, that is the name of the macro. And inside the parentheses, we provide the macro variable name. Suppose we are going to provide here two macro variables, macro var1 name and macro var2 name. These are the two variables. After then we have SAS code. The ending of the macro is %mend, and we are calling macro %macro name, whatever we provided at the starting point. And inside the parentheses, we provide the value of macro variable. Macro underscore var1 underscore value, that represents the value of first macro variable. Macro underscore var2 underscore value, that represents the value of second macro variable. These two macro variables are local macro variables. This is the fourth way we can create macro variable in SAS. And fifth one is SAS macro variable in proc SQL using into clause. In this method, we can create SAS macro variable using proc SQL procedure. Syntax is given here, proc SQL, semicolon, select macro underscore specification, that means that we have to select variable name, variable selection into macro variable name from source of the data from which table we are going to select variable and quit. This is the fifth method. In this way, we can create SAS macro variable by using 5 different methods. That's all about question number 50. Thank you. SAS interview question and answer. Question number 51. Describe a scenario where you had to use a macro. How did you go about building the macro? This question is asking about describe a scenario where we can use SAS macro and how can we create it. When a business needs to get a result in which the same SAS code is needed to run multiple times, then SAS macro is applicable. SAS macro feature avoids repetition of the code and allows them to use again and again as needed. We have a sample example here. Suppose we need to calculate descriptive statistics of numeric field of 10 different tables. Suppose we are going to calculate number of record, number of missing record, minimum value, maximum value, mean value, median value, and standard deviation. In this scenario, instead of writing the SAS code to get descriptive statistics 10 times, we use following macro and provide the table's name as parameter. To complete the process, we have to follow 2 steps. First step, creating macro, and second step, calling macro. First step, creating macro. It starts with %macro. Then we have to provide macro name. Stat underscore macro is macro name, and inside the parentheses we provide macro variable name, which is DSN. This variable is local macro variable. We are going to calculate descriptive statistics. That's why we are going to use proc means procedure. Proc means data equal ampersand DSN dot. That means we are going to call macro variable here, and we are going to provide options. N means mean, max, mean, median, standard deviation. Run, and we are going to close macro %m end. In general, after proc means statement, there is another statement which is var statement. That means we provide the variable name. That means we are going to calculate statistics for that specific variable. But in this example, var statement is missing. That means this code is going to calculate descriptive statistics for default value. Default is all numeric variables. This macro is going to calculate descriptive statistics for all numeric variable present in each tables. After then, we have to run this code. After successful run, we are ready to use macro code. Second step is calling macro. To call the macro, we start with %macro name, start underscore macro, and inside the parentheses, we have to provide the value of macro variable. Macro variable name is DSN, and its value is sasshelp.class. This is the first table. We have 10 different tables. All tables lie inside sasshelp library. That's why just we have to change the dataset name. Those 10 tables are as follow: class, fish, shoes, cars, iris, baseball, heart, product sale, lake, and demographics. When we run calling macro, then we will get 10 different set of the result. 4 result set are shown on the right side. That means result from class, fish, shoes, and cars. When we run same set of the code, then we will get exactly same result. This is the first set of the code, that is the creation of SAS macro, where it starts with %macro, macro name, stat underscore macro. Inside the parentheses, we provide here DSN, dataset name. It is macro variable, which is local macro variable. Proc means data equal ampersand DSN dot. We provide options, run, and closing macro. Let me run this set of the code first. It shows here it ran successfully because we did not observe any error messages. Now we are ready to use macro. Let me go to back code, and we are going to run calling macro section. There is a table name class, fish, shoes, cars, iris, baseball, heart, product sale, lake, and demographics. Let me run this calling macro. When we run this calling macro, it will display 10 different result set. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. That means simply by running calling macro, it produces the result. That means each calling macro that uses macro above macro. In this way, SAS macro avoids repetition of the code and allow to use them again and again as needed. That's all about question number 51. Thank you. SAS interview question and answer. Question number 52. Can you explain a situation where you have used proc SQL select into clause to create macro variable? This question is asking about where can we use proc SQL select into clause method to create macro variable. If you have previous experience, can you please explain it? If we need to use certain value or values from the variable of a table to further processing steps, then we can change that value to macro variable value and use it back where necessary. One of the previous work experience is explained here. While updating master data table, if the code runs successfully, then process status code changes to dot. If the program throws error, then process status code changes to corresponding number. That number represents certain type of the error. In such a scenario, after fixing error, we need to change number to 0. That means it is ready to new run. Sometimes it is not efficient to go to check MDT process status table, identify corresponding ID, and change the status code. In this situation, it is better to run just below code that changes the status, where it has used proc SQL select into clause to create macro variable. From left side table, the table name is MDT process status table. It has two columns, one is ID, another one is process status code, where one of the ID 231 corresponds to number process status code 44. That means
it is showing some type of the error. Then after fixing this error, we have to change this 44 number to 0. In such a scenario, we use proc SQL select into clause. First step, we are going to change this value, 231 value, to value of macro variable value. In this first step, proc SQL select id into proc underscore id, where proc underscore id is macro variable name, from drj.mdt underscore process underscore status. That means drj is permanent library, where mdt process status is table name, and we are using where condition, where process status code not in dot and 0. That means we are going to identify the process status code equals to certain number and quit. Next step, we are going to print value of this macro variable in our log window. That's why we use %put ampersand proc underscore id. Proc underscore id, that is the variable macro variable name. When we use ampersand proc underscore id dot, that means we are calling that macro variable here. When we run first set of the code, then it will create, or it will convert this id value 231 to the value of proc underscore id macro variable value. The next step, now calling and using macro variable value, proc SQL, we are going to update this table, drj.mdt process status table, and set process status code equals to 0, where id equals to ampersand proc underscore id. That means where id equals to value of this macro variable value, which is 231. That means we are going to change this row. When value of id is 231, that change the status code to 0. That means we are going to change this 44 to 0. After running the second set of the code, then this table will change to as shown on the right side. That means 231 value id correspond to process status code to 0. It has changed 44 to 0. If we run same set of the code with a SAS window, then we will get exactly same result. We have the two set of the code. Before running this code, let me check mdt process status code first. That code is inside drj library, and the table name is mdt process status. Let me check that table, where id 231 corresponds to number 44, process status code 44. That means we have to change, after fixing error, this value 44 to 0 value. Let me go back to the code and run this first step. That means we are selecting id, and we are going to convert that id value to macro variable value, where macro variable name is proc underscore id, and we are going to display that value in our log window. Let me check first one. Then let me check log. Then here ampersand proc underscore id, that value is here 231. This is the value of macro variable value. Let me go back to the code, then run second part of the code. That will change to 0, 44 to 0. From the log window, it says here one row was updated in drj.mdt process status table. That means it has changed. Let me cancel previous data first. Refresh it. Now I am going to check that table, drg library, going back to MDT process status table. Initially this value was 44. Now it has changed to 0. That means we have changed 44 value to 0 value. In this way, if we need to use certain value or values from a table to proceed to further steps, then we can use procSQL select into clause method to create macro variable and use its value for the processing steps. That's all about question number 52. Thank you. SAS interview question and answer question number 53. How do you combine 20 years monthly data to the history table? This question is asking about how can you combine multiple years of data which is recorded as monthly data to the history table with efficient way. There are multiple ways to combine monthly data to history table, but one of the efficient way is using SAS macro code. In this process, we use macro code with proc append procedure so that the every month data will append with one after other. Sample code is given here. First of all, we have to define the library name where the monthly data is located. Suppose lib name is ABC and monthly data is located inside this monthly underscore history folder. Next step, we are going to create SAS macro. It starts with %macro student underscore loop. This is the macro name. Then inside the parentheses, we are creating 3 macro variable: start, end, and base. The value of those 3 variables will provide at the end of the macro while calling macro. Next step, we use proc delete data equal ampersand base dot. That means we are going to append monthly data with base table where name of this base table is provided at the end of this calling macro. If there is already data in this base table, it will create the problem. That's why we are going to delete initial data from the base table. That's why we use proc delete data ampersand base dot and run. Next step, we use here do loop. That means it starts with %do and %until the start date is greater than end date. This is the valid condition. Until that valid condition, do loop will continue. After then, we use %put creating data for which date it will display in our log window. Every date, every monthly date, when it creates data, then it will display the information in our log window. Next step, we use proc SQL create table, student underscore list table, and this table is created from monthly data. This is the ABC is the live name, student underscore list underscore ampersand start. This is the format of monthly data table name. And we create monthly data from this library. Next step, proc append base. We provide the base table name and data. The data comes from student list which we have created above. And force option is used and run. That means we have created monthly data. That monthly data is append with the base table and it will continue until this start date is greater than end date. It will valid when January to December. That means every month it will increase by 1. But in case of December to January, that means while jumping from December to January, difference between, for example is a difference between December 2009 to January 2010, or December 2010 to January 2011, and so on. Difference is 89. So, following trick is applicable in such a scenario. In this case, we use percent %if, that means the if condition is used, percent %if, percent substring function is used, substring, substar, and we use here ampersand start date, comma, 5, comma 2 equals to 12, then use this condition. What does that mean? For example is here, substring function. Inside this parenthesis, we use 2010-08, 5, 2. For example, it says here, it starts with 5th position. That means it starts from here, 0, and it will take only 2 characters. That means it will take only 08, or it extracts only 2 characters, that is 08, for example. And similarly here, if this value, extraction value is 12, then percent let start, ampersand eval function is used. In case of SAS macro, without eval function, it cannot aid mathematical, it cannot work mathematical function here. So to calculate or to use the mathematical function, we use percent eval function, ampersand start date plus 89. That means it will add and it will gives the final result. But without percent eval, it will display the value of start date and plus and 89. It will not add with each other. Next, percent else. If this condition doesn't match, then just add with 1. That means January to February, February to March until December, month increases by only 1. That's why we add plus 1. Finally, we end the do loop, percent end, and we close macro, percent m end, and finally we call macro, percent strand underscore loop, and we provide the value here. In this example, for simplicity, I have taken class dataset. I have copied class dataset 13 times with a different month name from 2009-06 to 2010-06. This is not a real practical example. This is only for the application of this macro, how to use this macro. In case of a real practical application or example, it can be credit card monthly data, it can be monthly application data, it can be auto loan monthly data, it can be customer data, it can be monthly sales data. But whatever I am using here, this is not exact practical example data here. Only for simplicity, how to use this macro. I'm using that class data 13 times and I'm trying to add that class data. That means 13 month of data I'm going to combine. When we run this set of the code, then we will get the result as shown on the right side. Partial data is shown on the right side first table. It says total rows 247. That means each month it has only 19 record. 19 times 13, it is showing here 247 record. It looks simple, but if we have 20 years of monthly data, then total number of month will be 240 month, then it will be the huge number. In such a scenario, this macro is applicable. Similarly, in case of log window, it shows information like this. The data set combined output has 247 observation and 5 variables. If we run same set of the code with a SAS window, then we will get exactly same result. This is the SAS window, and first step is creating library, lib name ABC. This is the location where monthly data is located. Next step, macro creation, macro name student underscore loop, 3 macro variable. Next step, deleting base data. Next step, using do loop and creating student list data for monthly data. Next step, appending monthly data with base table. Next step, we are using logic here. That means while jumping from December to January, we have to use following logic plus 89. And finally, we end do loop and finally close the macro and calling macro. This is the complete code. When we run this set of the code, then we will get exactly same result. Let me check that combined output. Total rows 247. That means each month it has only 19 record, and I am going to combine only 13 month of record. That's why 13 times 19, 247. Let me check log. In case of the log, it says here at final point, the data set combined output has 247 observations. For the each month, it will show each month data after completion. First of all, 2009-06. When it reads, that means it says here, it has read 19 rows and 5 columns. And after then, when it completes with the second, 2009-07, it combines data here. Combined data has 38 observations. In this way, by using SAS macro, we can combine multiple years of monthly data to the history table. This is the example. That's all about question number 53. Thank you. SAS interview question and answer. Question number 54. What is the use of %sysfunc function in SAS macro, and give an example how to use it. This question is asking about what do you mean by %sysfunc function in SAS macro and how do you use it. There are a number of base SAS functions which are not directly available in SAS macro. %sysfunc is used to enable those functions to make them work in the SAS macro code. But following functions are not available with %sysfunc. Those are diff, input, put, dim, lag, resolve, simget, lbound, hbound. Those functions cannot be applicable with %sysfunc in case of SAS macro code. Here is the use of %sysfunc function. First scenario is sample code 1, where data step is used to create SAS macro variable. By using underscore null underscore, we create the data step, but it won't print data. By using %let, we create SAS macro variable today underscore date equal %sysfunc today, that means that it will count number of days from 1st January 1960 to today's date. It counts the day. And finally, we have to display in terms of certain format. Date 9 format will display 2-digit day, first 3-character month, and 4-digit year. The example is as shown here, right side, 05 March 2024, and run. It will print on our log window when we apply %put ampersand today underscore date. That means it will print today's date on our log window. The result is as shown on the right side. It will print 05 March 2024, today's date. Sample code 2, checking the existence of SAS dataset. We have a macro code here. It starts with %macro. Data underscore check, this is the macro name. Inside the parenthesis, we use dataset name DSN. This is the macro variable. And value we will provide at the end of calling macro. We use condition %if %sysfunc parenthesis exist parenthesis ampersand DSN %then. That means if this data set ampersand DSN, we will provide value here at the end of macro calling. If this data exists, then do the following step. That means create a report where a title is a report printed on %sysfunc inside the parenthesis today, and we provide the format here, date 9, and proc print data, whatever we provide, and run. %int, that ends the do loop. %else, if not. %put, the data ampersand DSN does not exist. It will print on our log window. %amid, that ends the macro code. And finally, we call macro %data underscore check, and we provide the data set name. First of all, we provide here sasshelp.class. When we run this code, then it will display as shown on the right side second table. The heading looks like report printed on 05 March 2024. That means today is resolved into today's date. And data is as shown on this right side, second table. But we have printed here only partial data. But it will display all 19 data records. Next step, suppose we are going to check another dataset ABC, sasshelp.abc, whether this dataset exists in this sasshelp.library or not. %data underscore check sasshelp.abc. When we run this last line of the code, then it will display on the log window the data sasshelp.abc does not exist. That means that this data does not exist in this library. If we run same set of the code with a SAS window, then it will display the same result. First part of the code, data step, %let today underscore date, and we are using here %sysfunc today and format, and we are going to print this date today underscore date in our log window. Let me run this first part. This is the log window, and it displays here 05 March 2024. This is today's date. Let me go back to the code. For the second part, first of all, I am going to run macro code. This is the macro, data underscore check macro name, and if condition is applied, if that data exists, then it will print a report. If not, it says here the data does not exist. Let me run first macro part. It ran successfully without error. Then I'm going to check first data. That means SAS_self.class. Let me run this first part. Here's the result. Heading is report printed on 05 March 2024, and this is the complete data, but this is the report. And finally, when I run last line of the code, then what does it say? It says here the data SAS_self.abc does not exist. That means this data does not exist in SAS_self library. In this way, we can use %sys function in case of the SAS macro code. That's all about question number 54. Thank you. SAS interview question and answer question number 55. What are the commonly used SAS macro functions? This question is asking about what are the commonly used SAS macro functions in SAS macro language. Most commonly used SAS macro functions are as follow: %eval, %syseval, %index, %length, %substr, %upcase, %lowcase, %scan, %sysfunc, %str, %nrstr, %quote, %nrquote, %uncode. In this video, first 7 SAS macro functions are going to be explained, and the remaining 7 functions will be explained in next video. First one is %eval. It evaluates arithmetic and logical expressions using integer value. That means suppose we have two macro variable x and y, and its value is 7 and 8 respectively, and we are going to create another macro variable z by using %eval function. %eval, inside the parentheses we use $x plus $y, where $x is 7, $y is 8. 7 plus 8 with eval function, that means with %eval function, it evaluates arithmetic and logical expression. Then it becomes here 7 plus 8 becomes 15. But without %eval function, the result becomes inside the parentheses 7 plus 8, because these 7 and 8, these values are string values. Number 2, %syseval function. It evaluates arithmetic and logical expression using decimal values. It is also called floating point values. Suppose we have two macro variable L and M, where value of L is 7.2 and M is 3.25, and we are going to create another new variable N by using %syseval function, and inside the parentheses we use $L minus $M. That means $L is 7.2 minus $M, its value is 3.25. With the help of %syseval function, result becomes 3.95. But without %syseval function, value of N becomes inside the parentheses 7.2 minus 3.25. Number 3, %index. It returns the position of the first character of a string. That means suppose we have a macro variable a, and its value is SAS macro function, and we are going to create another variable b by using %index. That means we are trying to get
the position of character C. Percent index ampersand A, comma C. In this example, we are going to identify the position of first occurrence of character C in this macro variable value, and we are going to print that value in our log window. That's why percent put C position at ampersand B. When we run this code, then we will get value of this B equals to 7. That means 7th position that indicates the character C. Let me check that one. First position, second, third, fourth, fifth, sixth, and 7th. This is the first character C, and its position is 7th position. Number 4, percent length. It returns the length of the string. Suppose we have a macro variable x and its value is Maryland, and we are going to print the value of length in our log window. That's why percent put the length of ampersand x is percent length inside the parenthesis ampersand x, where ampersand x is Maryland and its length, it evaluates the length, and its length is 8. It will display 8. That means 1, 2, 3, 4, 5, 6, 7, 8. Fifth one is percent sub-str. It will extract subcomponent of string variable. That means it will extract sub part of string variable. Suppose we have a same macro variable x and value is Maryland, and we are going to create another macro variable y by using sub-str function. Percent sub-str, inside the parenthesis we use ampersand x, and we use here 5, 4. This 5 represents the 5th position. It starts with the 5th position and it holds only 4 characters. And we are going to print that value in our log window. That's why it will display land, L-A-N-D. Let me check here. 1, 2, 3, 4, 5. It starts with the 5th position. That means from L, and it takes 4 characters, L-A-N-D. That is the result. Number 6, percent uppercase. It converts a resolved macro string value to uppercase. We have taken same example here. Macro variable x and its value is Maryland, and we are going to change this Maryland value to uppercase. That means another variable is y by using percent uppercase and percent x, and we are going to print that value in our log window, and final result becomes Maryland, but all character appears uppercase. And 7th one is lowercase, or simply percent lowercase. It converts resolved macro string value to lowercase. Here we have same example, and finally we get the value in our log window, but all character becomes lowercase. If we use same SAS macro function with example and run with a SAS window, we will get the exactly same result. This is the first one. By using percent eval function, variable x and y, value 7 and 8. When we run this code, first code, it becomes here 15. And without percent eval function, what will happen? Let me check that one. without %eval function, its value is inside the parenthesis 7 plus 8. Second one, the use of %syseval function. First one is L, second one is M. L value is 7.2, M value is 3.25, and this is the, we are going to create another macro variable N. Let me run this one, and it value becomes here 3.95. That means L minus M, it becomes 3.95. And without eval function, let me check here. Let me check without eval function what happens. Its value becomes here 7.2 minus 3.25. That means here I'm going to remove this ampersand as well, sorry, percent as well. It becomes here 7.2 minus 3.25. Similarly, next one is index. It gives the position of the C character, first C character. Its value is 7. That's correct. Because here 1, 2, 3, 4, 5, 6, 7. And this the length one is here. It should display the length of this meridian. Its value is 8. That's correct. And next one is here substr length. That means it starts with 5th position, it takes only 4 characters. The final value becomes length. That's right. And uppercase converts into uppercase. Yes, Maryland converted to the uppercase. And last one is lowercase. Yes, every letter that converted into lowercase. In this way, we can use SAS macro function in SAS macro language. That's all about question number 55. Thank you. SAS interview question and answer, question number 56. This question is continuation of question number 55. The question was, what are the commonly used SAS macro functions? I have already explained 7 SAS macro functions in video 56. In this video, I am going to explain remaining 7 SAS macro functions. Number 8, %scan. It extracts the nth word of the string. Suppose we have macro variable var and its value is var1, var2, var3, and we are going to create new macro variable final underscore var by using %scan function. %scan, inside the parentheses we use ampersand var, comma 2. That means we are going to select or extract second O. That's why we will get the result var2. Number 9, %sysfunc. %sysfunc executes base SAS functions or user-defined functions. Suppose we have a macro variable string 1 and its value is x01-x20, and we are going to change x by y. Then we use base SAS function translate with %sysfunc, because without using %sysfunc, translate cannot be applicable. Here, by using %sysfunc, translate ampersand string 1 y comma x. That means value of x is replaced by value of y. As a result, we obtain final result y01-y20. Number 10, %str. During the compilation of macro definition, %str masks, that means that removes the normal meaning of special characters and mnemonic operators. For example, here, suppose we have a SAS program, and this program is written in case of SAS macro variable. That means program 1 is macro variable and its value is SAS program proc print semicolon run semicolon. When we recall this macro variable %put ampersand program 1, it will print simply proc print, because the semicolon indicates here it will stop the program. As a result, we obtain proc print. But suppose we need to print proc print semicolon run semicolon. In such a scenario, we have to use %str so that it removes the normal meaning of semicolon. As a result, we obtain proc print semicolon run semicolon. This is the result with %str. Number 11, %nrstr. In addition to above mentioned special character and mnemonic operator with %str, %nrstr mask or remove the normal meaning of ampersand and percentage. Example is given here. First one is we are not going to use %nrstr. That means we are going to print today's date, and also we are going to print today's date by using sysfunc. And second one is we are going to use %nrstr. What is the difference? Difference is here. Without using %nrstr, we get today's date, 16 March 2024, and here also 16 March 2024. With using %nrstr, it doesn't resolve the date, because this ampersand, normal meaning of the ampersand is removed here. That means this is ampersand is only for the character in this case. That's why it doesn't resolve the date. Same as here, %sysfunc. Number 12, %quote. %quote functions work same as the %str, but it works during the execution of macro language. In case of the macro language, there is a two-step process. First one is compilation, second one is execution. In general, in case of compilation, it checks the error. If everything is okay, then it pushes to the execution. Here is one example here. We are using one macro code by using %macro. dpt1 is macro name, state is macro variable, and we are using here if condition, logical condition here. %if ampersand state equals to va, %then %put, that means Virginia DMB. That means it will print in our log window. %else %put other DMB. If not, it will print other DMB. It is ending the macro %min dpt1, and we are calling macro here %dpt. Suppose we are going to give a name of the state, Oregon, OR. But in this case, when we use OR, actually it is the Oregon state. But in this example, it will assume OR as a logical operator. That's why it will result error. In such a scenario, we have to use %quote with ampersand state, so that it will assume that this OR is not logical operator, OR is a string. That means the OR represents Oregon or string value. Then by using %quote, it will resolve our problem. Number 13, %nr quote. This function works same as the %nrstr, but it works during the execution of the macro language. Last one is %uncode. It helps restore the meaning of any special characters and mnemonic masked by the quoting during the macro execution. We have example here. Suppose here is a macro variable val and its value is use of uncode. Let another macro variable test val, and we are using here %str, %code, and %val, %code. Suppose we are using this macro variable test val in another macro program, another SAS program, and when we use this macro variable value, then it will result error. Error is shown in the right side. That means it says here expecting an arithmetic expression. In the second example, when we use uncode with the test val, then it will resolve the issue. That means it will remove or it will restore the meaning of any special character and mnemonic masked by the quoting during the macro execution. If we use those functions in actual SAS program and run, we will get the exactly same result. Let me run that code. This is the first code. First code is here, %scan. This the var is variable name. Its value is var 1, 2, and 3. And we are going to create another new variable, final underscore var, by using scan function. We are going to extract certain word. That means second word in this example. Let me run this one first. The result is var 2. That's correct because we are selecting from second word. Next, %sysfunc. We use %sysfunc with translate base SAS function. That means y will change by x will change by y. Yes, we have here y01-y20. That's correct. Next one. Next program is here %str use. Let me run first one without using %str. It prints simply proc print because after the semicolon it will stop the program. But if we need whole program, then we use %str. This example, it will print whole program, proc print semicolon, run semicolon. Next one, nrstr. First example that is without using nrstr, and second one is with using nrstr. Let me run first program. It resolves today's date. And what happened if we run second program? It won't resolve because here is the normal meaning of ampersand and percent has removed here. Those are characters only. Next one is here quote. Initial condition is I'm using without quote, and here dpt1, that means the macro name, and variable is used here. Variable value is Oregon. What happened? Let me check this one. It throws error. That means in this example, OR means here not Oregon. OR means it is a logical operator. That's why it is throwing error. Next, what happens if I use percent code? Let me use percent code, then run this one. Now it will produce the correct result. That means Oregon is not equal to Virginia. That's why we are getting result other DMB. That's the correct result. And last one, use of uncode. First program without using uncode. What happens? Let me run this one. It is showing some error because we have here code, and inside the code we have a value of SAS macro value, macro variable. Let me use uncode and run the program. It resolves the issue here. In this way, we can use SAS macro function in our SAS language. That's all about question number 56. Thank you. SAS interview question and answer. Question number 57. What are the differences between mprint, mlogic, and symbolian in case of SAS macro options? Mprint, symbolian, and mlogic, all three options are used for SAS macro debugging. In this video, I am going to explain mprint, symbolian, and mlogic separately. At the end of this video, we can identify what are the differences between them. First one is mprint. Mprint displays all the SAS statements of the resolved macro code and is used for debugging macros. That means mprint is used for debugging macros and it displays all the SAS statement with resolved macro. We have a SAS code. Options we use mprint, no mlogic, no symbolian. That means only mprint is activated. Macro name test, and we are creating two macro variable, input and output. We are using proc means procedure. Data, we are providing here ampersand input. At the end of this macro, we are going to provide input data set name, and variable is msrp because we are using cars data. Output is here ampersand output, and we are giving its name test, and we are ending the macro %mend and calling macro here %test. saself.cars input and test is output. When we run this first set of code, we will get result as shown on the right side. This is the log window information. It displays here proc means data equals to saself.cars, no print. That means ampersand input is resolved into saself.cars. And next one is output out equals to test. That means output out equals to ampersand output, that is resolved into test. In this way, mprint displays SAS statement with resolved macro. Second one is symbolian. Symbolian displays the result of resolved macro variable reference to the SAS log and used for debugging purpose. That means in case of the symbolian, it displays only resolved macro variable value. Here we use options symbolian, no mprint, no mlogic. That means only symbolian is activated. we use same set of macro code. When we run the second set of the macro code, we will get the information with a log window as shown on the right side, second table. It says here, macro variable input resolved to sasshelp.cars and macro variable output resolves to test. That means only resolved information is printed on log window. Next one is mlogic. Mlogic and no mlogic. That means mlogic traces the execution information in SAS log, and no mlogic, it doesn't trace the execution information. Here, mlogic, when we use mlogic option, it causes the macroprocessor to trace its execution and to write the trace information to the SAS log. It is used to debug macro. This is the general use. Each line starts with mlogic and microprocessor displays the following message. First one is beginning execution. Second one, value of macro parameter at invocation. Third one, execution of each macro program statement. Fourth one, displays whether each %if condition is true or false. And fifth one, ending execution. We will get those information in our log window. Here is a SAS code. Option is mlogic, no mprint, no symbolgen. That means only mlogic is activated. We have a SAS code, macro code here, %macro. Macro name is dpt1, macro variable name is state. And we are using here if condition. %if this state name is VA, then it prints Virginia DMB. If not, it prints other DMB. End of the macro. And we are providing here state is Oregon. When we run this third set of code, then we will get the result as shown on the right side. This is the log window information. From here it is clear that it starts with mlogic, and first line is beginning execution. Second line, parameter state has value OR, that means state is resolved with value OR, Oregon. Third one is if condition is false. Fourth one is here is a percent put DMB, that means it is printing other DMB. And fifth one is ending execution. This is the pattern we obtain in case of mlogic option. Then what is the conclusion? Conclusion is mprint option prints all SAS code with resolved macro in log window. Symbolgen option prints resolved macro variable message in log window. And mprint option identifies and prints the macro logic information in the log window. If we use those options with the SAS code, then we will get exactly same result. Let me run that code with the SAS window. First one is use of mprint. No mlogic, no symbolgen. Same macro code is used. Let me run this first code. This is the output result, but we are going to check log window. It's the log information. That's why mprint, it prints all SAS statement with resolved macro. This is the first statement, proc means data sasshelp.cars. This is the resolved value. Similarly, output out is test. This is the resolved value. Next one, let me go back to the code. Second code for symbolgen. That means in case of symbolgen, we use option symbolgen, no mprint, no mlogic. When we run second set of the code, and when we check with log window, it displays or it writes the information only resolved macro information. That means Macro variable input resolved to sasself.cars. Macro variable output resolves to test. That means Symbolgen only prints information on log window with a resolved macro variable value. Then next third one. Let me run this third set of the code. Option is mlogic, no mprint, no Symbolgen. When we run third set of the code, then it displays the message as shown in this window. That means the first one is starting mlogic, beginning execution. Second one, parameter state has value OR, it is a resolved value. Third one is if condition, it is false. Fourth one is it will print value with our log window. And last one is ending execution. From here, it is clear that mprint, Symbolgen, and mlogic, three options are used for the debugging macro in case of SAS macro language. That's all about question number 57. Thank you.
SAS interview question and answer question number 58. How does multiple ampersand macro variable resolve? Where do you use it? This question is asking about if you have more than one ampersand, how does it resolve macro variable? And where do you use it? Single ampersand is used to invoke, that means to resolve the value of macro variable. Sometimes multiple ampersand come in application, which is used to allow the value of a macro variable to become another macro variable reference. That means if value of a macro variable is used as another macro variable name, then in such condition we use multiple ampersand. The macro variable reference will be rescanned until the macro variable is resolved. Following rules are applicable to resolve multiple ampersand. Rule number 1. The macro processor reads a macro variable from left to right. That means it resolves left ampersand first, then resolves a right ampersand. Here is an example. We have a simple code here. We use option Symbolgen that will print a resolved macro information in our log window. We have three macro variable, %let book, book is its value is story. Next one is %let story and its value is funny. And third one is %let funny story, its value is fiction. In above example, the value of one variable value is another macro variable reference. In the example here, story is value of book, but this story is macro variable in the second condition, where its value is funny. Let me explain first rule. That means it reads from left to right. Suppose we are going to print this value here. Value is %book %story. That means it will resolve first %book resolves to story, and %story that resolves to funny. And finally we get here like this. Book resolves to story and story resolves to funny, and finally that value becomes story funny. Number 2, rule number 2, for multiple ampersand, 2 ampersand resolves to 1, and during the macro resolution process. That means it resolves, if we have 2 ampersand, then it resolves 1 first. After then it resolves a macro variable value. Here is example. We are going to print this value 1, percent put value 1. Its value is 3 ampersand here. Story ampersand book. In this condition, what happens first? First, this 2 ampersand resolves to 1 ampersand. Next, ampersand story that resolves to funny. At the same time, ampersand book resolves to story. That's the result we get here. 1 ampersand funny story. And next step, it will resolve ampersand funny story to fiction, because here funny story, its value is fiction. Rule number 3. While working for multiple ampersand, the rescan rule applies until no more ampersands are left to resolve. That means this process will continue until no more ampersand are left to resolve. Here's an example. Suppose we are going to print value 4 and its value is here 6 ampersand story to ampersand book. What will be the result? First of all, 6 ampersand that resolves to 3 ampersand. 1, 2, 3. Because this is even number, that's why it will remain here a story. And 2 ampersand that resolves to 1 ampersand and becomes here book. This is the first step. Then next step, 2 ampersand resolves to 1 ampersand. Ampersand story resolves to funny. At the same time, ampersand book resolves to story. It became here funny story. And next iteration, third iteration, ampersand funny story that finally resolves to fiction. In this way, multiple ampersand works. In the log window, we observe here 1, 2, 3. That means first 3 that comes from 6 ampersand that resolves to 3 ampersand. 1, 2, 3. And fourth one that comes from second, 2 ampersand equals to 1. And fifth one that comes from the second step. This 2 ampersand resolves to 1 ampersand. That's why we obtain here fifth one. And story resolves to funny, book resolves to story, and finally funny story that resolves to fiction. If we run same set of the code with SAS window, then we will obtain same result. Let me run this code with the SAS window. We have same code here, options symbolium that will print in our log window all resolve macro variable value. We have 3 macro variable, %let book, its value is story, %let story, its value is funny, %let funny story, its value is fiction. Let me run first one. That means that we are going to print this value where we are using ampersand book, ampersand story. And what will happen? This is the result. That means, first of all, macro variable book resolves to story. That means first it will resolve left. After then, story resolves to funny and it moves to right. And finally, we obtain story funny. This is the final result. Let me go back to the code and comment this line first. I'm going to uncomment second one. It will apply our second rule. What will happen? Let me see here. Okay, this 2 ampersand resolves to 1 ampersand according to second rule. After then, we have 1 ampersand story, that story resolves to funny, and ampersand book resolves to story. And we have, it becomes here ampersand funny story, and it will resolve into fiction. That's the result. Let me go back to the code, comment this line, and uncomment third one. Multiple ampersand. Let me run this code. Okay. We have here first three resolution 1, 2, 3, that comes from 6 ampersand changes to 3 ampersand because it works every pair, it converts or resolves into 1 ampersand. That's why 2, 4, 6, that converts into 3, first step. Then next one is 2 ampersand converts into 1 ampersand. It's the fourth line, fourth one it gives here. And after then we have 3 here. Then first two pair, 2 ampersand resolves to 1 ampersand, that will obtain from fifth one. After then we have ampersand story, that resolves to funny. We have ampersand book, that resolves to story. And finally we have 1 ampersand funny story, that resolves to fiction. This is the value. Finally we obtain fiction. In this way, multiple ampersand words are resolved in case of macro variable. That's all about question number 58. Thank you.
SAS interview question and answer. Question number 59. What are the differences between calls input and SIMGATE in SAS macro? This question is asking about differences between calls input and SIMGATE in a SAS macro with suitable example. There are following differences. Number 1, calls input. Calls input is routine. That means a procedure that can accept arguments but does not return any value. But SIMGATE is function. That means it accepts arguments and also it returns certain value. Number 2, calls input is used to assign a value produced in a data step to a macro variable, where SIMGATE returns the value of a macro variable to the data step during the data step execution. We have following example. First one, calls input. Syntax is calls input. Inside the parentheses, we provide macro variable name m_var. It should be inside the quote, comma, m_value. That represents the value of macro variable. Sample code is given here. Option symbolgen. Data step we use, data test. It has one variable, month 5, and its value is May. Calls input, that means we are going to create a macro variable mvar, and we are using value of this macro variable, value of month 5. That's why mvar, comma, month 5, where value of month 5 is May. And we are going to check whether it has created macro variable or not. That's why we are going to print %put macro_var equal &mvar. That means it will print resolved macro variable value in our log window. When we run this first set of the code, we will get result or information in our log window as shown on the right side, first table. Here, symbolgen says that macro variable mvar resolves to May. That means calls input has created macro variable mvar and its value is value of month 5, where month 5 value is May. Second one is SIMGATE. Syntax is SIMGATE. Inside the parentheses, we provide macro variable, and finally it gives certain value. Sample code is given here. Option symbolgen, data step, data test 1, where it has two variables. One is month 4, its value is April, and month 5, we are going to take the value of month 5 by using SIMGET function. SIMGET, inside the parentheses we use macro variable MVAR and run. When we run second set of the code, then we will get result, output result as shown on the last table. That means it has two column or two variable. One is month 4, where its value is April. Next one is month 5 and value is May. This value May is obtained by using SIMGET function. And when we check with the log window, we do not see any change in our code. If we use same set of the code in our SAS window, then we will get exactly same result. Let me run with the SAS window. This is the first set of the code. That means option symbolion, data test, month May, calls input. We are going to create macro variable MVAR, and its value is value of month 5, where month 5 value is May, and we are going to print whether it has created macro variable or not. Let me run first set of the code. We are going to check with log window. In case of log window, we observe here macro variable MVAR results to May. That means calls input has created macro variable and its value is value of month 5, where value of month 5 is May. Let me go back to the code and run for second set of the code, where we have used simput function to get the value of macro variable in data state. Let me run second set of code. This is the result, that means the output result. We have two variables, month 4 and month 5. Month 4 is April, month 5 is May. This value May is obtained by using SIMGET function. If we check with the log window, we do not see any change in this code. In this way, we can differentiate calls input and SIMGET in SAS macro. That's all about question number 59. Thank you.
SAS interview question and answer. Question number 60. How do you call SAS macro from the external location? This question is asking about if the given SAS macro is stored in different folder, then how can you call SAS macro from that external location? Following two methods are used to call SAS macro from the external location. First one is using %include. Second one is using autocall macro facility. Let me explain first using %include. In this method, we start with %include. Inside the code, we have to provide file name with folder location. Your file name is macrostat.sas and folder location is interview/SAS_macro. And macro name is frequency. Next step, we have to call macro. That means %frequency, that means we are calling frequency macro. In this method, we need to provide the file name of the SAS macro, that means macrostat.sas is file name, and frequency is macro name. One important point is here, folder location and file name all are case sensitive. When we run two lines of code, then it will produce the result as shown on the right side, first table. It gives the frequency procedure. That means it produces the frequency of status variable. Let me explain second method. Number 2, Using autocall macro facility. In this method, we use macro options, where options m auto source SAS autos equal inside the parenthesis SAS autos tilde slash SAS underscore macro. That means we have to provide the folder name in which SAS program is stored. That should be inside the code. Next step, we have to call SAS macro. That's why %stat1, where stat1 is SAS macro name. It can include SAS variable here. That means dataset name we have to provide. Its value is sasshelp.cars. When we run these two lines of code, then it will produce the result as shown on the second table. In this method, we use SAS macro options m auto source SAS autos and provide the folder name with tilde, this symbol, in which the code file is saved, which is shown as the above. This procedure that gives the result as shown on this second table. That means this is the means procedure. It produces the statistics of numeric variable of cars dataset. If we run the same set of code with our SAS window, then we will get the exactly same result. Let me go through the SAS window. This is the first code. That means first method using %include. Inside the code we provide file name with folder location and frequency is macro name. Then second one is using autocall macro facility. We use options m auto source SAS autos. Inside the parenthesis we use SAS autos, and inside the code we use tilde sign slash SAS underscore macro. This is the folder in which SAS macro code is stored. And stat1 is macro name. Let me check macro. That means macro is stored inside macrostat.sas. That means this is another program here in which two macros are stored. First one is macro name is frequency. Second one is macro name is stat1. First macro, it generates the frequency table. Second macro, it generates the proc means, that means the means procedure table. Let me run first one. When we run these two lines of code, then it will produce the frequency table. Frequency table of status variable in case of sasshelp.hard dataset. Let me go back to the code and run second set of code. Here we have provided dataset name sasshelp.cars. A macro name is stat1. That means it produces the statistics of all numeric variable of cars dataset. Let me run these two lines of code. It has produced the result as shown on this window. That means it has produced n total number of records, mean value, standard deviation, minimum value, and maximum value of all numeric variable. In this way, we can call SAS macro from the external location by using two methods. First one is by using %include, and second one is using autocall macro facility. That's all about question number 60. Thank you. SAS interview question and answer, question number 61. You have given a credit card customer data. Manager is asking the list of customer name in a row with comma separation. How do you solve the task? This question is asking about how can you create a list of customer name in a row with comma separation. We can use SAS macro. By using SAS macro, we use select into clause in ProcSQL to collect all the name list with as-defined separation. In this example, we have separation is comma. For simplicity, I am using class dataset from SAS help library, where I am going to create a list of name where age is greater than 13 and name list is separated by comma. Sample code is given here, ProcSQL semicolon, select name into colon, macro underscore var, this is the macro variable name, separated by comma, this should be inside the code, from sasshelp.class, where age greater than 13, semicolon, quit, semicolon, and I'm going to print the macro variable value in log window. That's why we use %put and %macro underscore var, semicolon. When we run this first set of code, then we will get result information in our log window as shown here. That means all macro variables are resolved. And the result is shown here. All names are separated by comma. Next one is our task is to create a data set. That's why we use data step, data name underscore list. This is the data set name, where variable name is name and variable name is given by, or this value is we obtain from macro variable. That's why we use here %macro underscore var and run. When we run the second set of code, then we will get the result or output data set as shown on the right side, second table. It has one variable where variable is name and its value is name list of the all name in class dataset where age is greater than 13, and this name is separated by comma. When we run same set of code with our SAS window, then we will get exactly same result. This is the first set of code, ProcSQL semicolon, select name into colon, macro variable name, macro underscore var, separated by comma, from sasshelp.class. Filter condition is applied where age is greater than 13, and we are going to check whether it has created macro variable or not, and we are going to print the value of macro variable in our log window. When we run this first set of code, the result is shown in this window. Let me check log window here. In this login window, it has created list of the name where age is greater than 13 and name list are separated by comma. Let me go back to the code. For the second set of code, we are going to create data set, data name underscore list, where variable is name. Let me run this code. It has created one data set. It has one variable name is name, and its value is list of the name in class dataset where age is greater than 13 and all names are separated by comma. In this way, we can create the list of the customer with separated by comma in a single row by using ProcSQL select into clause. That is the one of the method to create macro variable in SAS macro.
That's all about question number 61. Thank you.
SAS interview question and answer. Question number 62. How can you export categorical data into a single Excel worksheet with a category in the different tab? This question is asking about how to export data into Excel worksheet with a category into different tab. To solve such type of the task, we can use dataset which contains the categorical data. In this example, I am taking demographics dataset from SAS Help library, where I am going to export data according to region into a single worksheet with a different tab. Before going through the SAS program, following steps are very useful to be familiar with the SAS dataset. First step is identify the data location. In this example, it is easy to identify because it is from SAS Help library, but sometimes we have to write the code and to extract the data. In this example, library name is SAS Help and dataset name is demographics. Let me check the data first. This is a library, SAS Help, and checking here demographics dataset. It has 18 columns, that means 18 variables, and 197 rows. And we are concerned with a region variable because we are going to export this data into Excel worksheet according to region but into different tab. Let me go back to the slide. Step 2, identify number of variables and variable type. We know number of variables are 18. To identify the variable types and further information, we use proc contain procedure. Proc contain data saself.demographics, varnum and run. Varnum option is used to display the variable without sorting. When we run this first set of code, proc contain code, then it will display the result as shown on the right side first table. It has 18 variable and we are concerned with variable region, where variable region is character variable and its length is 6. Step 3, identify distinct count of required variable, that means the region, and corresponding count. From step 2, we know that variable region is character. That's why to identify number of distinct count for the character variable, we use proc-fric procedure. That's why proc-fric data saself.demographics and table region and run. When we run the second set of code, then we will get the result as shown on the right side, second table. It contains a region, frequency, percentage, cumulative frequency, cumulative percentage. Your frequency column represents the number of count corresponding to the number of region. That means AFR, it has 46, AMR 35, EMR 21, EUR 55, SEAR 11, WPR 29. Let me go to the SAS window and run these two set of code. The first set of code is proc contain data saself.demographics varnum run. Let me run this code. It displays number of information, but we are mainly concerned with second last table, where it has information about the variable, name, type, length, format, and label. It has total 18 variable and variable region is character variable and its length is 6. Let me go back to the code and run the second set of code. It has displayed frequency table. It has 6 distinct regions, and frequency column represents a corresponding count of the region. Let me go back to the slide and follow the step 4. Following microcode can be used to export the region-wise demographic information to a single Excel worksheet with a different tab. This is a SAS program where we can use different ways of SAS macro variable creation procedure and its use. In this code, we use mainly 4 different ways of macro variable creation procedure and its use. To simplify this code, I have classified this code into 4 different groups. First group is A. In this group, this is the ProcSQL select into clause macro variable creation method. It creates a list of the macro variable region underscore list 1 to region underscore list total. That means total means we have here 6. And it stores the value of a region. That means region underscore list 1 equal AFR, region underscore list 2 AMR, and so on. Group number 2, that means the B. %let method to create the macro variable. In this method, it creates a macro variable folder path where its value is /home/the seat700/interview/SAS underscore macro. This is the value. Group C. This is the iterative %to macro variable creation process. In this step, it creates the macro variable I, where its value starts from 1 to total count of number of regions. In this example, its value is 6. And it creates a 6 different data set. Data set name, test underscore AFR, test underscore AMR, and so on, which is written in this code. Because it starts with %to I1 to total count of region, and we create data test underscore $& region underscore list $I. That means when value of I is 1, in first execution, $& resolves to single ampersand, $I resolves to 1, then $region underscore list 1, that goes to the its value resolved to AFR. That's the first region. Similarly, when value I equals to 2, then this value becomes here test underscore AMR. When its value is 3, this value becomes test underscore EMR. In this way, it resolves value of I 1 to 6. Then group 4. This is a SAS macro. A macro name is demo underscore print. %amount that ends the macro. And we can use demo underscore print to call the macro. When we run this whole set of code, then it will export demographics dataset into Excel worksheet where its name is demographics.xlss with a different tab according to region. Exported Excel result, sample result is shown here. It has 6 different tabs with corresponding region. First one is dataset name test underscore AFR. Second one is test underscore AMR, and so on. Let me explain how does it work. First step is it stores all region into macro variable region list 1 to region list 6. Then next one is %do method that takes first of all value I equals to 1, that resolves the value AFR. That means data set name becomes test underscore AFR because we have selected here region AFR, and folder name we are exporting into this region, and set name is same as the data set name. Similarly, when I equals to 2, then it resolves to the second region, which is AMR, and data set name becomes test underscore AMR, and tab name is test underscore AMR. In this way, it exports the demographics dataset into single worksheet, demographics.xlsx, but with a different tab, as shown on the exported Excel result. Let me go to the SAS window and run the code. It's the same set of code. First set of code is proc_sql select into clause, where it stores all region into different region underscore list 1 to region underscore list 6, because in this example total number of region is 6. Then we mainly concern with the %do loop here. When I equals to 1, then first execution, second 2 ampersand resolves to the 1 ampersand, and ampersand I resolves to the 1. Then it becomes here ampersand region underscore list 1 that resolves into value of first value is AFR. Similarly, when I equals to 2, then it resolves to second region, that is AMR. Let me run this code. Code ran successfully. Let me go to the log window. There's no error. Here I am checking here region underscore list 1 is AFR. It has resolved to AFR, and total number of region is here. Total number of region is 6. Next one is first data set name is test underscore AFR, and it has total count is 46, and it has exported to this demographics.xlsx Excel sheet. Similarly, second one is AMR, total count is 35, and exported to this Excel sheet with the tab name is same as dataset name. Next step, let me check the Excel sheet here. Let me go to this path, where path is interview. Inside the interview, SAS macro, there is an Excel data set is here. Excel sheet demographics.xlsx. This is the Excel sheet. Let me download this one. Let me increase the size here. Okay. Now from this Excel sheet, we can see here it has 6 different tabs. First one is test underscore AFR. Second one is test underscore AMR. Third one test underscore EMR. Fourth test underscore EUR. Fifth test underscore SEAR. And sixth test underscore WPR. That means data has exported into a single Excel sheet, but with a different tab according to region. In this way, we can export categorical data into a single Excel worksheet, but with a different tab by using SAS macro code. That's all about question number 62. Thank you.